Hi, welcome to Francois Maths class. Today we are going to look at conditions for parallel and perpendicular lines under coordinate geometry 1. When you look at parallel lines, we say that when two lines are parallel, it means both of the lines are inclined to the positive x-axis. So when you have this plane, you have this line and that line. Let's give this one L1. You have theta, and this one L2, theta. So this angle and this line and this line, we are saying they are parallel because they are all inclining at the positive x-axis. So we can say that tan theta is equal to our M1. If you, as we said previously when we were dealing with the finding gradient. So this one, our M1 is equal to that. Then tan theta is also equal to M2. So this one we can say that our M1 is equal to M2. So our M1 is equal to M2. The M1 is for the first line, the L1, and the M2. The M is the gradient. The L is the line. So the L1 gives us the same one gradient, that's tan theta is equal to M1. Then this one also gives us tan theta is equal to M2. But since they are parallel, it means that they are having the same gradient. That's parallel. But when you talk of perpendicular, with perpendicular lines, one of the line is equal to the negative reciprocal. One of the lines is equal to the negative reciprocal of the other line. So when you have one of the lines to be this, then the other line will give you that. So they form an angle of 90 degrees. So if this is your L1 and this is your L2, it means that their angle tan M1 is equal to negative 1 over M2, because that gives you the negative reciprocal of the other. So it means that M1 times M2 is equal to negative 1. So when you multiply their gradients, it should give you negative 1. And that is for perpendicular. So when a question is given, and probably lines are given, and we are saying that you should find another line where one is perpendicular or parallel, you should know, depending on what the question is demanding from you. If it's perpendicular, it means the gradient of this one is going to use the negative reciprocal of that. Then if they are parallel, it means they are going to use the same gradient to find that. Let's find or get a question and see. Find the equation of the line which passes through the point and perpendicular to the line 2y minus 3x plus 1 equal to 0. So we are supposed to find another equation with that is passing through the point. I think the point is then point 1, 3. The point 1, 3. And perpendicular to this line. So now we are saying that that's another line that you are going to find should be perpendicular to this. So first, it means we have to get the gradient. But our equation is 2y minus 3x plus 1 equal to 0. And the point to be used is 1, 3. So it means first we have to find the gradient from this. And to find the gradient, we have to make y the subject. So 2y is equal to, this one to go here, 3x minus 1. We have to divide here by 2, here by 2, here by 2. So our y is equal to 3 on 2 minus 3 on 2x minus half. So with this, our gradient m is equal to 3 on 2. But from the question, it says it is perpendicular. And as we said, perpendicular means that it means it should, if we have the other gradient should be negative reciprocal. So it means if this is our m1, our m2 should be negative, that's negative 2 on 3. So it means the new equation that we are going to form, we are going to use negative 2 on 3 and this point. So we have y minus y1 equal to our m into bracket x minus x1. So y minus our point is 1 3, so x1 y1. So 3 is equal to, now since it's we are using the negative reciprocal, that's negative 2 on 3 x minus 1. So we multiply through, we have 3y minus 9 is equal to negative 2x plus 2. So we have 3y minus, this is minus, so plus 2x minus 9 minus 2 equal to 0. So we have 3y plus 2x minus 11 equal to 0. And that is one question. This question, they asked us to find the equation perpendicular to that. Let's try another question. Let's try another question. And this question is find the equation of the straight line which passes through the midpoint of the line joining the points R 1 2 and S 2 negative 3 and perpendicular to the line 3x plus 2y minus 5 equal to 0. We are saying that we should find the equation of the straight line which passes through the midpoint of the line joining the point R. So it means that we need to find the midpoint. Okay, so it means the point that we are going to use for this one, we need to get the midpoint. And the midpoint of R and S, or RS, is equal to half, because we have our point x1, y1, x2, y2. So with this, we have half x1 is 1 plus x2, 2. Then 2 plus negative 3. So half of this one will give us 3, then half of negative 1. So we are having 3 on 2, negative 1 on 2. And this will be the point that we are going to use for the question. 3 on 2 and negative half. And we are saying that this point is perpendicular to that. So if it's perpendicular to it, means that we need to get the gradient from this one. So we have our equation AOX plus 2y minus 5 equal to 0. So this we need to get our gradient. And our gradient, we can make y the subject. So 2y minus 3x is equal to negative 3x plus 5 over 2 over 2 over 2. So y is equal to negative 3 over 2x plus 5 over 2. So our gradient m will give us negative 3 on 2. But we are saying that it's perpendicular to that. So if it's perpendicular, it means we are going to use the negative reciprocal of that, which give us m is equal to 2 on 3. And the point 3 on 2 minus half. Find the new equation. So to get this, we use the formula y minus y1 equal to m into bracket x minus x1. So y minus our y1 is negative half equal to our m is 2 on 3 into bracket x minus 3 on 2. So with this, we have y plus half is equal to 2 on 3 x minus 3 on 2. So let's see, y plus half is equal to, this one will give you 2 on 3x minus, and this one 2 will cancel that, so minus 1. So we can multiply through by the LCM, and the LCM here will be 6. So here by 6, here by 6. So 6 multiplied, we have 6y, and plus 3 is equal to, this will cancel that, so we have 4x, then minus 6, minus 6. So with this, we can group our like terms and have 6y minus 4x plus 9 equal to 0. 6y minus 4x plus 9 equal to 0. And this one gives us our equation. So the new equation that we are supposed to find is 6y minus 4x plus 9 equal to 0. And this brings us to the end of the topic conditions for parallel and perpendicular lines. Continue to subscribe to Francois Maths class, or you can also contact me on my number 0246 426343. Have a nice day and bye-bye.